Our
this
channel
element.
is for your
It will
growth in
come here.
statistics.
It will assign 1 or 0 to this element. It continues till the end to this n subscript 1 item. Therefore, if it assigns 1 here and assigns 0 here, for instance, and assigns 1 here, summing all of them, when you are adding 0 to anything, it doesn't change anything. So when you are summing this xi, it's as good as you are summing the 1 there. Because when you are summing 0, 0 doesn't change the value. So that's why we are saying that the total number of successes y subscript 1 is giving us sum. I is running from 1 to n1 of xi. The same thing applies here, that we are going to define what y what 2, and this y2 is going to be sum that I is running from 1 to n what 2 of what x what I. So this is total number of successes from sample 1. This is total number of successes from sample 2 coming from population what 2, and this one coming from population 1. Now, we want to determine, first of all, what is the distribution of y1 and what is the distribution of y2. When we talk about the distribution of y1 and y2, we are going to make reference to with replacement and without replacement. But what we are discussing now is for with replacement. Now, if sampling is for with replacement, it means that if I come to this population 1 and I draw the first sample, say, and say 1, I must return this 1 to this population before I draw the next sample. And I continue in that order now till I get all the elements up to my N1. And because the sampling is for with replacement, it means that each of these elements in these samples are independent of what? Of each other. And each of the elements can either be what? Be success, or it can either be what? Failure. And any random variable that can either be success or failure at any particular point in time is a Bernoulli random variable. So each of these items is a Bernoulli random variable. And we are told that when we sum Bernoulli random variables, independent Bernoulli random variables, that we are going to get a binomial random variable. And of course, you know that this my yi here is the sum of the independent Bernoulli random